That's the worst score you could possibly do.
Actually,
Worst score.
I have discovered. Good job, Colin. I'm proud of you.
I don't like to talk.
You fail so bad. It's like I'm taking your brain.
And we're gonna be singing
You are built different.
I'll be a mediator.
But you somehow make it make sense.
I'll be driving. I think I got all the way
I'll be trying next week. My tennis
Technically, you will be driving. Technically, you will be driving for about 20 days next year.
I get my permit in 20.
Your birthday's in December. If you get your driver's license on your birthday.
All right, hey, let me have your attention here. Okay, all the grades should be updated now through the chapter 7 test. All right, so we're going to move into chapter 8, which deals with something called factoring. And so we're going to kind of build up to that. It's basically the opposite of FOIL. Okay, in FOIL, you multiply things together, and in factoring, we break them apart into products. And you've done some of this, and you'll recognize it. Probably back to Mrs. Hattinger, or who else was the teacher that?
Hattinger?
7K? Yeah. What is it? Oh, maybe Mr. Walker.
Very little.
Walker's a legend.
Reardon, maybe?
I
Very
had
terrible grades in classes. They couldn't take that.
one.
That was my worst math grade ever. I got like an 80%.
Okay. Hey, quiet, please. All right, now, the first thing here we talk about is factorization. Whole numbers are multiplied to find a product are called factors. A number is divisible by its factors. Just a little bit of terminology here. You can use the factors of a number to write the number as a product. The number 12 can be factored several ways. It's basically what multiplies to give us 12. So it could be 1 and 12, 2 and 6, 3 and 4, 1 times 4 times 3, or 2 times 2 times 3. Those all multiply to 12. Can we at least agree on that? Okay, but they're sometimes in different order. What is called a prime factorization is all the numbers are prime numbers. That would be a case there. What is a prime? Well, let me see something here. All right, let me go backwards. Okay, so what are all the factorizations? What are all the factors of 24? This isn't on your guided notes, so just pay attention. What are all the factors of 24? So let me start you off. Always start with 1. 1 times 24. Now, I just want two numbers that multiply together to give me 24. What else? 2 times 12. Christian, what else? 3 times 8. Anything else here? Jordan?
4 times 6.
Now, 4 times 6 is going to be equivalent to 6 times 4. You don't need to list that separate. Okay, so that's not going to be a separate pair. Is there anything else that multiplies together to give us 24? Okay, so you need to be able to figure those out. You need to be able to come up with those. For 40, 1 times 40. And then you say, all right, does 2 work? And I say 2 times 20. Can you come up with a whole number that multiplies 3? No. But what else?
Well, I have 8 times 5.
There's something before that.
There's 2 times 20. Weird.
4 times 10.
4 times 10. You're a little too slow for me today. 4 times 10.
We're doing adding switch.
And then Christian,
8 times 5.
8 times 5. I'm going to write it as 5 times 8. I'm going to start from low to high so I don't miss anything, and so I don't write anything twice. So I go 140, 220. 3 doesn't work. 4 times 10, 5 times 8. Now, if you want to, if you have a number and you're not sure, so you're maybe you know 3 doesn't work, but if you're not sure, you take 40 divided by 3, and it gives you a decimal. Okay. If I think 2 works, but I can't remember exactly what number is, I do 40 divided by 2. So that means 2 times 20 is 40. And then 40 divided by 5 is 8. So 5 times 8, 40 divided by 6 gives me a decimal, so that doesn't work. And then 40 divided by 7 is another decimal. Now I'm back to 8. And since I've already used 8, I've listed all the possible factors. Okay. The order of the factors does not change. So whether you did, 2 times 20 or 20 times 2, it still gives you 40. But in this case here, we're looking for what's called the prime factorization. So of all these cases, each one of these could have been reduced or broken down because 6 can be made 2 times 3. 4 is 2 times 2. 4 is 2 times 2. But 2 times 2 times 3, can you multiply any two numbers together to get either any of those? Other than a 1. We don't want to use that. No. It's called a prime factorization. Do you remember what a prime number is? No? Okay. Well, that's why this is short here. So right here, under that remember, see where that says? It says prime number is exactly 2 factors, exact itself in the number 1. Basically, 1 is not considered. Jordan?
I had our hand. We had our hand.
What's that?
We had our hand up to answer that.
Oh, go ahead.
What you just said.
Oh, I'm sorry. I gave it away. Can you give me some prime numbers?
Yeah, 7. It's 11.
Okay, 11. What's the first prime number? 2.
First prime number, 1.
Hey. Okay. 2 is a prime number. 3 is a prime number. 2 is the only.
You good there?
You all right? Okay. There you go.
Oh. Went all over the class.
He's not happy with you.
I'm gonna get you guys now.
Yeah, for everybody here. 2 is the only even prime number because every even number can be divided by 2. So everything else is odd. So 2, 3, 5, 7. 9 is not because 9 can be divided by 3. 11, 13, 17, 19, 23. There's an infinite number of prime numbers, but we want to figure out all the prime numbers that are in a factorization. Okay, so just pay attention to this. What we're going to do, and this is the method we're going to do, this factor tree to find the prime factorization. So basically, you find any 2 factors that multiply to 98, and you keep breaking them down into their prime numbers. 2 times 49 is 98. 2 is a prime number. Can't break that down any further. But 49 can be broken down into 7 times 7. Are those both prime numbers? Yes. So this is going to be 2 times 7 times 7. That would be its factorization. Okay. So for 40, we're going to do a factor tree. It doesn't matter where we want to find the prime factorization of each number. It starts with any 2 numbers that multiply to 40. And then we break it down from there. All right, so Connor, can you come and give me any 2 numbers that multiply to 40?
10 and 4. 10
All right, he says 4 and 10. I'm always going to go smallest number first, not that you have to. Take a look at each one. Can you multiply any 2 numbers to get 4?
2.
2 and 2. Can those be broken down any further? No, they are both prime numbers. So 2 and 2. And 10 is going to be 2 times 5. Those are all prime numbers. So the prime factorization for 40 is we say it is 2 times 2 times 2 times 5. If you multiply all those together, what does it have to multiply together and equal? It has to equal 40. Now, in some cases, how can you write, when I have 3 2's, that is 2 to what power? 2 to the 3rd power. So sometimes you'll want to do that. Sometimes we want to leave it as all three twos. Sometimes we want to say, all right, it's just 2 to the third power. Because 2 to the third power is going to equal 8, and 8 times 5 is going to give me 40. There's no, and we always are going to list smallest to largest. All right, so 33.
And understand with 40, we had 4 times 10. If we had started with 8 times 5 or 2 times 20, we would have ended up in the same place. Right? So you don't have to like kind of guess which one we want to see first. It doesn't matter where you start.
Pick any 2. All right, what about 33? Sam.
3 times 11.
Yep. Now, does 3 break down any further? Does 11 break down any further? Nope. So 33 can be written as 3 times 11. That is its prime factorization. That is the prime factorization. Okay, so the next one you got 49. Okay, what multiplies together to get that?
7 times 7.
7 times 7. Is anything else multiplied together to get that? Christian?
1 times 49.
Okay, 1 times 49. You never need to use for this, you don't need to use the 1 because then you're still with the 49.
Yeah.
So always at least use, and you're correct, 1 times 49 is 49, but when you're prime factorization, always use something with the 2 or above. So in this case here, it's going to be 7 times 7. Does 7 break down any further? Nope, it is prime. And so it's 7 times 7, or it is 7 squared. All right, what about 19? So 19.
19 times 1 is it?
Yeah, the only thing, 19 times 1, that doesn't get us anywhere. That doesn't really break 19 down. So you're just going to put prime. It is a prime number. It is a prime number. Now you can get some big numbers. So you got to be, you got to make sure you have some multiple branches on your tree. Now we're going to do it 2 ways. We'll just see it out there. So what about, because I know people think about any 2 numbers that multiply to get 840. Any 2 numbers that multiply. Jordan?
Oh, I was raising my hand for something
Oh,
else. There's 2 B's and 2 C's.
there are?
Yeah.
Oh, do I have to come to the?
Okay, well, you'll just have to put that on our evaluation at the end of the year. I apologize.
Make a note there.
That was not, I failed a little bit today on those notes. Joe,
4 times 210.
he says 4 times 210. 4 times 210. So 4 times 210. 840. Can anybody else give me another different pair? So we can start it 2 different ways. Say it.
6 times 100.
6 times 100 and what?
40.
40. So she says 6 times 140. 6 times 140. All right, if we do this right, we get the same answer. So I'll show you. So if you did 6 times 140, start that way, and I'll go through it. If you did 4 times 210, we'll start that way. Well, 4, I know. 4 is 2 times 2. Now, one thing, sometimes it helps your factor tree to be a little bit smaller. If you pick numbers closer to each other, it doesn't make it better. It just makes it maybe a little bit smaller. So 210. Well, what's going to be 210?
105.
What's that?
2 times 105.
2 times 105, what else? Sure.
6 times 35.
6 times 35, anything else? 3 times what?
70.
3 times 70. Does 10 go into 210?
21 times.
Yeah, how many times?
21.
Now I'm going to use that one because those are the 2 closer numbers of the ones we said, because now 10 times 21. Now, once you get to 2 and the 2, I'm going to circle those because so I don't forget about them. 10 is 2 times 5. Those are both prime numbers. 21 is 3 times 7. Those are both prime numbers. Now, when I write the prime factorization, I want to keep everything in order. How many 2's do I have when I'm done? Jordan?
2 cubed.
Say it again.
2 cubed.
2 cubed. 2 to the third. Now I'm going to list it first, then write it the second time. So there, you got 3 of them. 1, 2, 3. Then go. Do you have any 3's? Yep, 1, 3, right? And then I got 1, 5, and then I got 1, 7. So if I use my calculator and I say 2 times 2 times 2 times 3 times 5 times 7, it better give me what? Better give me 840. Now, what Jordan said, he said I can write that as 2 cubed times 3 times 5 times 7. So hopefully what means a cube something is, you were a little bit fuzzy on that, it's coming together. All right, I'm going to go back to 6 and 140 just to show you get the same thing. 6, 2 times 3. I'm going to use 10 times 14. Like the closer they are together, it just makes life a little bit easier. That's 2 times 5. That's 2 times 7. So I got 1, 2, 3 2's, a 3, a 5, a 7. Doesn't matter which way you start. Doesn't matter which way you kind of branch off. As long as you use 2 numbers that multiply together, you'll be fine. So that's how you do the prime factorization. GCF, greatest common factor. Factors that are shared by 2 or more whole numbers are called common factors. The greatest of these is the greatest common factor. So you have the same thing on your paper. Okay. So if you look at 12, 1 times 12, 2 times 6, 3 times 4. So those are all factors. 1 times 32, 2 times 16, 4 times 8. Common factors that they share, 1, 2, and 4. The biggest one is 4. So that means that's the largest number that will divide into 12. That's the largest number that it will divide into 32. It divides into both of them. Like 6 will divide into 12 but not 32, and 8 will divide into 32 but not 12. 4 is the biggest one. Sometimes you can figure this out mentally. Sometimes you got to go through the work. All right, now flip it over. This one's not on your paper, so just pay attention. Find the GCF for each pair. Well, what you can do is you can do the prime factorization, do the factor tree. Once you got that, 26 is 2 times 13. 52 is 2 times 2 times 13. If they have anything in common, they both have a 2, they both have a 13, you multiply those together, that's 26. Does 26 go into 26? Yeah. Does 26 go into 52? Yeah, that's going to be your GCF. Your GCF cannot be bigger than the smaller number. So you always want to test. Is that my GCF? So is 26 my GCF? Just test it. Does it go into the other number? If it is, you're done. All right. 12 and 16. Does 12 go into 16? Evenly. No, so it's not your GCF. And you might be able to figure this one out in your head. What's the GCF for 12 and 16? That's 4. It's the biggest number that goes into both. Okay, so this one here, GCF, equals 4. All right, this one is nowhere near as easy. So you got 144 and 300. I'll put your hand down for that. All right, here's what I'm going to tell you to do. There's a process, so you're just not guessing because it's easy to miss the first one. All right, I want you to do a factor tree on 144. You got 2 people there. One of you do 144, one of you do 300. Okay, one of you do a factor tree on 144, one of you do 300.
I'll do a
3 and 100.
That's gonna be the easy one. Divide by 2. The next half hour.
Yep.
Thanks for that. All right.
Should I throw it? How was
You get it clipped over record. Whoa. No?
I gave a period.
All right, now make sure that we match up. So 144 is 12 times 12. 3 times 4. 3 times 4. 2 times 2. 2 times 2. 300. I'm going to use 10 and 30. 2 times 5. 3 times 10. Another 2, another 5. All right, here's what you need to do. For 144, list them all in order. So take a look. Make sure I don't miss any. I'm going to circle them. How many 2s do you get for 144?
4.
Did you get 4 of them? I'm not going to write it as 2 to the 4th. I'm going to write it as 2 times 2 times 2 times 2. And then I got 2 3s. For the second one, make sure you guys match up. For 300, I got how many 2s do I have? Or do you have? Did you get 2 of them? How many 3s? 1. And then how many 5s? Okay. Get that down. Get that down.
Always has to be some complication.
Oh, that's just the way it is.
That's the way it is, Joe.
Oh.
Right.
it? 12. Told you.
I would believe you, I just have to write it down. That's a lot of numbers. You got that, Rich?
Get this down. Okay, hey, listen. Now, here's what you do. You look for what they have in common. Got a pair of 2s in common. Now, this one is out of 2s, so we cannot pair those up. They both have a pair of 3s. But this one has a 3, this one doesn't. So they have nothing else in common. So what you do, the GCF, is then you take each pair, one pair of 2s, a second pair of 2s, and a pair of 3s, and you multiply those together and you get 12. Don't multiply 2 times 2 and then 2 times 2. So you take that and you get 12. What we're saying our GCF now is 12 for 144 and 300. You don't necessarily have to go through that procedure for all of them, but like when you got 2 large numbers, it's very easy to miss and you pick a number that is smaller. All right, you see what you come up with for your GCF for 9 and 36. Do it however you want. And then also for 12 and 33. You just write it down for now.
No, I have a question about the other one.
Sure. Go ahead.
Doesn't 6 fit in both of them, but that's greater than 3?
But what's my GCF? The GCF is actually 12, which is bigger than 6.
Oh, okay.
Okay, so if I told you GCF was 3, then yeah, I'd be wrong. I'm using that wrong.
You guys play one Saturday?
Wednesday. We're supposed to play North tonight, but we can't. And then I didn't find it.
You get beat.
Oh, shoot.
Yeah, I know.
For nine, you got three times three. Thirty-six.
But 36 is good enough. But they have-
Yeah, I should have.
What did you get? Okay.
So you get a pair of threes and another pair of threes. So you
Get that, you're
multiply
good.
that together.
Oh, I bet you didn't use your head, did you?
Is that right? Yeah, one thing you want to do, try and like, think about it.
Dude, look at that.
You're like,
Hopefully, you wanna get to the point where for 9 and 36, you should try to make a mental, I don't know if guess is the right word, but a mental calculation as to what the GCF is. What do you think the largest number that goes into 9 and 36? And it all depends on how good you are with your factors. If you're really good with your multiplication factors, then you're gonna have a greater success rate. If you struggle a little bit, then you gotta know you're gonna do the factors. Christian?
3,
3, you saying that's a GCF?
I think.
That's a good guess, because 3 goes into both, but Allie's gonna tell us different. It's 9.
That's what I got, but I didn't trust myself.
Does 9 go into 9?
Yeah,
Does 9 go into 36?
I don't know.
You got a calculator?
I had 9 down, but I didn't trust myself. I didn't trust myself.
Okay. Well, 9 is 3 and 3. 36 is 6 and 6.
No, my name's T-I, that's 30X.
whatever X.
Okay. So our GCF ends up being 9. Now, when you do 4, what'll go into 12 and 33? Zach Walls? Just tell me the answer. The biggest number that goes into both is 3. That's it. So that is it. Now, we're gonna throw some variables at you. Don't make this complicated. Basically, we wanna know what they have in common. And just pay attention to this one. 15, you wanna do the factor tree on 15, but it's just 3 times 5. X cubed is x times x times x, 3 x's. 9 is 3 times 3, and you got 2 x's. What do they have in common? They each have a 3, and they each have a pair of x's. Your GCF will be 3x squared. For the variables, there's always going to be the smaller of the 2 exponents. If they both have the same variable, in the end, it's going to be the smaller one. Okay, that's a little bit of a shortcut. So in this case here, you got 18g squared and 27. All right, let's just kind of do this together. The factor tree for 18 is 2 and 9, and this is 3 and 3. For 27, it's 3 and 9, and then 9 is 3 and 3. So for 18g squared, I have a 2, a 3, a 3, and then I got 2 g's. So make sure you get that down. For 27, g to the third, I get 1, hold on, 3 3's, and then 3 g's. Now remember, what are we looking for here? We're looking for what they have in common. What they have in common. So I got 1 pair of 3's, another pair of 3's. That's it for the numbers. I got a pair of g's, and another pair of G's. So my GCF, multiply the numbers together, is 9, and you write G squared. 9G squared will go into 18G squared, and it will go into 27G squared evenly. There's no remainders.
Again, as long as that variable is the same, it's always the one with the lowest exponent. So G squared, they're always gonna have at least 2 G's down here, so that is gonna be your little shortcut for.
Hey, now think about this one. You right? Is that one already written down?
Yeah.
Can you come up with any number that goes into 8 and 7? Anybody?
No.
And 1 doesn't count. Okay, it has to be 2 or bigger. What's that? Well, this multiplies by 2 and 4, but do either of those numbers go into 7? Can anybody come up with any? No. Do they have the same variable?
3.5.
3.5 doesn't go into 8.
No.
Yeah, I know, but it has to go into 8 too. Okay, there's no GCF. Or no, hold on. The GCF would actually be, I'm sorry, I wrote that wrong. It'd be 1. I know.
Ruin our energy.
Joe, there's nothing to
Or at least you ruin that.
Here, write these down and I'm gonna give you the answers because we're running out of time. So, because these are, I want you to just think through them. So 12x and 28x cubed. What is the biggest number that goes into 12 and 28? Well, first of all, try 12. Will 12 go into 28? No. Will. So what, any ideas what the biggest number? Christian? 4. Now, I said pick the smaller exponent. So your GCF is going to be 4x. All right, what about this one? What will go into 27 and 45?
9.
9. Anything bigger? I don't think so. Now, what letters do they have in common? They only have one variable in common. It's the which one? X. And what did I tell you? Is it going to be, it's always going to be the smaller of the 2 exponents. So it's going to be 9x squared. Okay, so that'll be that case. All right. Obviously, we don't have enough time in class, but 527, 1 through 16.
I want the word